Guys, welcome to our next flipped classroom video. Today we'll be discussing combustion reactions. The learning objectives for today are to understand what a combustion reaction is, be able to distinguish between complete and incomplete combustion, and provide examples of combustion reactions. What is combustion? All combustion reactions involve a substance, usually a fuel, reacting with oxygen. When this happens, heat is released in the process. This means that these reactions are classified as exothermic. Exo meaning exit, so heat is exiting the system, but we'll learn more about exothermic reactions a bit later on. Burning is a combustion reaction that produces a flame. Now, sometimes in order to react something with oxygen, we need to have a bit of energy input first. For example, when you turn on the gas taps in science to light your Bunsen burner, it doesn't spontaneously combust, does it? In order for the methane gas to combust with oxygen, we need to provide it with some energy, such as that from the match you use to light the Bunsen burner. Only then does it react with the oxygen, as it has now got enough energy to do so. Most of our energy needs these days comes from the burning of fossil fuels. Examples include natural gas, coal, and oil. They get their names, fossil fuels, because they are formed from remains of dead plants and animals, and it takes thousands of years for fossil fuels to be made within the earth. Fossil fuels are called non-renewable because of this. They take such a long time to be made in comparison to how often we use them. So we use them a lot, but we're actually running out of fossil fuels because it takes such a long time to make them. Fossil fuels are hydrocarbon molecules, which means, as the name suggests, they are made up of only carbon and hydrogen atoms. Some examples of these include methane, propane, butane, and octane. All of these we use for different energy needs. Methane we use at school, it's the gas used for our Bunsen burners. Both propane and butane are used as portable gas bottles, and octane is a component of petrol. When fossil fuels undergo complete combustion, the products are always carbon dioxide and water vapour. So, as an example, when you light the Bunsen burner at school and the methane gas mixes and combines with oxygen in the air, we get carbon dioxide forming and water vapour, or gaseous water. Sometimes there isn't enough oxygen for the fuel to burn completely. This is called incomplete combustion. During incomplete combustion, there is less energy released in comparison to complete combustion, and instead of carbon dioxide, we either get carbon monoxide, which is a poisonous gas, carbon or soot, and water vapour. An example of combustion in nature is cellular respiration, which is how we get our energy. This is a slow combustion reaction happening within our bodies all the time. When we digest glucose, which is a sugar from our foods, and it combines with the oxygen we breathe, it releases carbon dioxide, which is what we breathe out, and water, which our body uses for other processes within the body, and most importantly, energy. This is the only way our bodies can gain energy for everyday functioning. If we don't consume enough food, we start feeling lethargic and less energetic because of this. Another example is a fuel cell. This is where hydrogen gas combines with oxygen gas to produce water. Although this is regarded as a clean type of energy, as there is no carbon dioxide, the reactants hydrogen and oxygen need to be constantly supplied to the cell in order for it to work. Another reaction is the reaction with magnesium and oxygen. When magnesium combusts to form manganese dioxide, or manganese oxide, it produces a bright light. We use magnesium for this reason in emergency flares. This concludes our video on combustion. If you've got any questions, please ask at the start of the next lesson, and we'll be starting it with another pop quiz.